Okay. Now, students, now see here. Now, the amplitude modulation itself is this is DSBSC demodulator. What is DSBSC demodulator? Can you guess? What should be the demodulator of DSBSC? So, can I use the amplitude detector? Can I use the amplitude detector as a demodulator for DSBSC signal? Tell me. So, can I use an amplitude envelope detector as a demodulator for DSBSC signal? No, it's not possible. Why? Now see here, this is message signal adding a suitable DC component and multiplied with the carrier, then that is nothing but an AM signal. Am I not? So you already remove the DC component. You are not interested on the DC. Now without DC, means this DC equals 0 means message multiplied with carrier, right? Message multiplied with carrier. So without DC, now this AM signal, this message and this carrier now multiplied, now that is called as, without DC, that AM signal is named as two sidebands, right? Two sidebands, and this DC is 0. Double sideband and suppressed carrier. Why? Because of this DC component, one carrier component is present. No, now that's why without DC, now this AM is named as a DSBSC signal. So now this is 0, DC is 0, the message signal multiplied with carrier. The message signal multiplied with carrier is, earlier we call it as AM, and now at that time we don't know. AM, right? Message signal plus DC multiplied with carrier is an AM, provided the demodulator is envelope detector. But here what happened? Now you DC is 0, message and multiplied with carrier is an AM signal, but without DC, that AM signal is named as double sideband. There are two sideband, FC plus FM, FC minus FM, and already DC is 0 means that carrier is component is also 0. Okay, this is the DSBSC signal, double sideband suppressed carrier signal. You know that. So now the demodulator of DSBSC signal. Now when DC is 0, there is no other option. When DC is 0 means definitely only one option. Now over modulation. Over modulation means mu is greater than 1. When mu greater than 1 means definitely the envelope detector will not work. Only the option is synchronous detector. Okay. And therefore, if DC equal to 0, which means that now without DC means mu greater than 1 means over modulation. Over modulation means no envelope detector. Envelope detector will not work. Only synchronous detector. Okay, only synchronous detector. No DC, mu greater than 1, over modulation, envelope detector will not work. Only synchronous detector. Okay, clear or not? So that is the reason why then we'll take the synchronous detector here. Now see here. Now this is message multiplied with carrier. This is a product modulator. Message multiplied with carrier. This is a DSBSC signal. Earlier we call it as AM signal. Okay. Now it is called as a DSBSC signal because DC component is 0. Now this is the transmitter part. This is the transmitter. Now at the receiver. Now this is a DSBSC signal. Input to the receiver is a DSBSC signal. This is a product multiplier. Now this is carrier. So DSBSC signal, this is a local oscillator generated signal. This is a synchronization. But there is a mismatch of phase. Let us assume there is a phase mismatch. So what is the output of the multiplier? Now see here. Now output of the multiplier at the receiver is, DSBS signal multiplied with local oscillator generated signal is this. So he just multiplied cos of A plus B, cos A cos B minus sin A sin B, multiplied and cos of square theta, and here we just use the two formulas. Now one is cos of square theta, which is nothing but 1 plus cos 2 theta by 2, and 2 sin theta cos theta, 2 sin theta cos theta, which is sin 2 theta. Now these two options which we are used, Okay, and we can get this one. Okay, now see here. Now this FC 2FC plus FM 2FC minus FM is not allowed. 2FC plus or minus FM is also not allowed because this is a low pass filter, is a low frequencies from 0 to FM. Okay, that is high frequency and band of frequencies are eliminated. So now what is the output of this demodulator? The output of this synchronous detector is AC square by 2 m of t cos phi. Now see here. This is output of synchronous detector is finally AC square by 2 m of t into cos phi. This is output of the synchronous detector. Now what happened? Now there is a chance of when phase is when phi equal to 0 degrees or 0 radians, when phi equal to 0, what is the meaning of that? There is a phase matching. Now transmitting side phase is 0 degrees, receiving side phase is also 0 degrees. Then when phase is 0 degrees, what is the output? Now output of the demodulator is, output of the detector is AC square by 2 into m of t. Now it is a perfectly synchronized message signal. This AC square by 2 you can easily eliminate it. This is perfectly synchronized. When phase is 90 degrees, output of the detector is, when phase is 90 degrees, output of the detector is AC square by 2 m of t cos 90 degrees, which is nothing but 0. Now output is 0, then when output equals 0, nothing is coming when phase is mismatching of 90 degrees, then this effect is called as quadrature null effect. This is quadrature null effect, and both carriers are perfectly synchronized here. Okay, but when phase is in between 0 degrees and 90 degrees, okay, now which means that if phase is in between means when phase is greater than 0 degrees and less than 90 degrees, then now what happens? Now output signal, now this is cos less than 90, less than cos 90 or greater than cos 0. Okay, now which means that now the output signal is, this is the output signal is multiplied by a factor of cos phi. Actually this is cos phi. Now that cos phi is cos 10, cos 20, cos 40, cos 45, cos 50, cos 50, cos 85 like this. So the output signal is multiplied by a factor of less than 1 because cos 90 is 0, cos 0 is 1, less than 1 factor is multiplied, such that then this signal strength, whatever the signal strength m of t should be, decreases. When the signal strength is decreases means the distortion will be increases. Now effect of noise will be more. When the noise effect is more, noise is dominating, then the signal to noise ratio is decreases. When the signal to noise ratio is decreases, then very less, then the demodulation is not possible. Now whenever the demodulation is not possible, then what is the use of increasing the cost, complexity, all these things? Now all these things are not at all working. Now when the demodulation itself is not possible, it is very difficult, and the synchronization by using a local oscillator providing how much phase, cos phi phase, extra hardware is required to nullify that phase is a very difficult task. It is very, it is not an easy task. Okay. And what is the disadvantage of this synchronous detector? Cost is increased, complexity is increases. Now synchronization is very difficult task to maintain that particular phase. Quadrature null effect, which is a dangerous effect, output equal to 0, and synchronous detector is not at all preferable practically based on those particular reasons. And we already saying that now this is not only the phase mismatch, there may be a chance of frequency mismatch also, but the dangerous effect is phase mismatch. That's why we are taking a phase as a criteria here to explain the operation of quadrature effect. Okay, there may be a chance of frequency mismatch also. Now this is the DSBSC demodulator, which is nothing but synchronous detector. Synchronous detector, which is the demodulator of DSBSC. And one more thing also I want to explain. Where there is no DC component, if your modulated signal does not involve any DC component concept, means if you are not adding any DC to the message signal before going for modulation, which means the DC is 0, carrier component is 0. When DC equal to 0, that is called a suppressed carrier. All suppressed carrier, the demodulation process is only synchronous detector. All suppressed carrier, the demodulation technique is done by only synchronous detector. In AM also, you use the synchronous detector only when DC is equal to 0. Okay, so that's why the practically the synchronous detector is not at all preferable because of these many disadvantages. We always go for analog detector, but the thing is just add a DC component. Okay, not on that.